Back to my math YouTube channel. In this video, I'm going to show you one more example on using the trig techniques for evaluating integrals. So the example that I'm going to show you is, I think this is going to be my example number 4. And I think I'm going to show you one more, so it will be like 5 examples on trig techniques, and then I want to move on to another type of method for integrating functions. Okay, so in this video I want to show you how to integrate a function which looks like this: integration of cosine to the power 4x dx. Okay, so let us try to figure this out. So guys, there's like probably a few different ways of doing it, and one of the ways is to break it down as a product of cosine square x times itself. Or what I'm going to do is I'm going to square this, because this is the same thing, 2 times 2 is 4, so I'll get back cosine 4x. Okay, so before we actually start using the trig techniques or using the right substitution here, what one has to do is, and if you have been following my videos, you would already know that what we have to do when we are trying to evaluate integrals for functions like which have a higher power, which are trig functions and have a higher power than 1, what we want to do is we want to like kind of break them down and bring them down to something in the linear power, like to power 1. Okay, so if we can bring them into power 1, then we can use some direct formulas or shortcut methods to evaluate the integral. But as such, we cannot just directly evaluate this integral. For that matter, any integral of this type where we have a trig function or a product of trig functions and the powers are more than 1. So we have to remind ourselves some trig identities, and in this case we have to think about the double trig identity for the cosine function. So guys, I'm going to remind you that here we have the double trig identity is cosine 2x equals to, so there are 3 ways of writing the cosine 2x. In this case, I'm interested in the cosine square, so I'm going to use one of the ways which involves a cosine. That looks like 2 cosine square x minus 1. And guys, you can find these identities on like a formula sheet. You can print that out from the internet, or you may also find them in your textbooks as well. So guys, the good thing about this is that we have a linear piece here to the power 1, and then of course we have a square here, but what we need is, in this case, we have a cosine square. So if I solve this cosine square, and I will be able to solve it in terms of cosine 2x, and you can already see that this has a power 1. And if we are able to convert this into power 1, then we would be able to actually evaluate this integral. That's the goal, guys, to bring that power down to 1. And in order to do that, one has to use substitution, and one also may have to use the identities, the trig identities. So in this case, if I solve for just cosine square x, so I'll have to first add 1 to both sides. And I will try to write those steps. So I'm going to say this is going to be 1 plus cosine 2x equals to, and on the right hand side I will be left with only 2 cosine square x. But I'm only interested in cosine square x because here I just have a cosine square x. So in order to get the cosine square x by itself, I have to divide both sides by 2. I have to divide this side by 2 as well. This 2 crosses out. What do I have? I have cosine square x equals to 1 plus cosine 2x divided by 2. So we are able to transform this cosine square in terms of a cosine double angle where the power is that invisible 1. So we're going to use this identity up here, and I'm going to substitute the cosine square x for this piece right here. So it's going to be 1 plus cosine 2x divided by 4, and then whole square. Of course, there's a dx with it. Okay, that is step number. Of course, this is step 1. Then we have to go on the side and try to see that identity, bring it back here, and substitute. Guys, from here, let us be careful. Sorry, this is still 2. But then when we square this thing, it will become 4. So guys, I can rewrite this as 1 plus cosine 2x whole square divided by 4, right? I just distributed this 2 with the numerator. Of course, we have to distribute with the denominator as well. Guys, this 4 here, we can just take it outside, and that's what we do with the constant. So it is going to look like this: 1/4 integral of this. And let us start actually, like, we cannot, again, just looking at the numerator here, we still cannot directly write the integral or evaluate the integral because there is still a square. So the first step we have to do is we have to try to write this out, expand it out. So expanding this out, either you remember the a plus b squared identity or formula, or one has to write these things out and multiply or distribute. So let us say we want to distribute this. So we're going to write this out as 1 plus cosine 2x, and you got to times it by itself. That is what the square here means. 1 plus cosine 2x, and of course there's a dx with it. Okay, so I'll have to get rid of this stuff so that we can like finish the whole thing. So but guys, there's probably one more step that I can do here. So let us squeeze in this much, 1/4 integral. Let us go ahead and distribute this. So 1 times 1 and all that, so you know how to do that. So 1 times 1 is 1, then 1 times cosine 2x is cosine 2x, cosine 2x. That takes care of the first piece. Then there's the second term, so plus, this time this is the same thing, cosine 2x, and the last term will be cosine 2x times itself is cosine squared 2x. Of course there's this, well, let us put this in parentheses, there's a dx here as well. Well, we can see here that we can combine some terms, and we can combine these two middle terms. They will add up to 2 cosine 2x, and then let us bring it up here and then see what we can do from here. I'll have to get rid of this. Let us get rid of this here. Okay guys, from here, I need more space, so I'm even going to get rid of these things. So from here guys, let's put a star here, and I'm taking it up right here. So I'm going to write 1/4, then integral, and inside the integral I have a 1 plus this is 2 cosine of 2x, and then I still have a plus cosine squared 2x, and then let's put it in parentheses, and then a dx. Okay. Now let us look at each of these individual terms here. There's 3 of them. Well, integral of 1, we can do the integral of 1, pretty simple. We can also do the integral of cosine 2x because the power is 1, and we can easily do it using a simple shortcut method, using a simple basic method. But again, we have a cosine square, and we don't have any direct way of integrating a cosine square function. Okay, so first 2 functions we can write the integrals for them. For the third function, again, we cannot write the integral right away, so we may have to go back and again try to rewrite this in terms of another double angle where the power of the cosine would be just 1, so that we are able to actually evaluate that integral. So we have to do the same thing what we did earlier here twice in this case. Okay, that is what makes this problem a little challenging. But guys, I'm going to show you all the steps. So let us try to first evaluate this first 2 integrals, and then we'll work with the third piece as well. So this is going to be equal to 1/4, and then let us break this down. So this is going to be integral of 1 dx plus the second term will be integral of, don't forget this is like 1/4 has to be multiplied the whole thing. Then it is integral of 2 cosine 2x dx, and then finally plus integral of cosine squared 2x dx. Moving on, guys, this is 1/4, and we know the integral of a constant is just with respect to dx is just x, and then in this case 2, we can already take that 2 outside. Then integral of cosine 2x, the integral of the cosine function is the sine function, so it's going to be sine 2x, but we also know that we have to divide by the derivative of the inner or the coefficient of the x. So the coefficient of x is 2, we got to divide by 2, and that 2 is also, this 2 is also the derivative of 2x, if you like to think in terms of dividing by the derivative. Okay guys, that takes care of these 2, and then plus this guy. Again, we cannot directly evaluate the integral, so what we're going to do is we're going to rewrite this as, so guys, again, let me get rid of some of the stuff here so that I can actually show you how to rewrite this as. So maybe we can get rid of, like, let us get rid of this. Let us get rid of all of this. Guys, here's the thing. We have the formula that we need is cosine 2x is, and this is the formula that I had already written on that side. So we know this is equal to, and that is something that you will you can find on the trig formula sheet. So cosine 2x is 2 cosine square x minus 1. This is the formula, this is a trig identity that you can find on a trig formula sheet or even some textbooks as well. Now guys, here I don't want cosine square x, I want cosine square 2x. So in order to get cosine square 2x, what we have to do is we have to make some changes in this particular formula, which are pretty simple, not too complicated. So this formula, we're going to rewrite this slightly differently. So it's going to look like cosine. I'm not going to work with 2x, rather I'm going to multiply this by 2, which will give me a 4x. But if I multiply this angle, because these are angles, the 2x and x, these are angles, right? And if I multiply this angle by 2, so what do we have to do with this other angle here? Of course, I have to multiply the other angle on the right hand side by 2 as well. So it's going to look like cosine square 2x here, and then there's a minus 1. So we're still using the same double cosine identity, but guys, since we want the cosine square of 2x, so we have to kind of double these angles. So, and that is mathematically correct. If I double this, all I have to do on the right hand side is I just have to double this angle as well. Now this guy, cosine square 2x, looks exactly what I want here to evaluate, right? So we can solve for this same thing. You add 1 to both sides, and then you have to divide both sides by 2. So finally you will end up with this. Cosine squared 2x will be equal to, I hope you will be able to do this on your own, this basic simple solving for the cosine squared 2x. It is just 1 plus cosine 4x divided by 2. And guys, this is exactly what we wanted. We had a square, we wanted to get rid of that square and get it in just power 1. Here you can already see that there's an invisible power 1. Okay, so we have cosine squared 2x already solved for. Now I'm going to bring it back here, and I'm going to, instead of writing cosine squared 2x, we are going to write 1 plus cosine 4x. Guys, this is a lot of steps, but we have to deal with these type of examples, so one has to go through and one has to do these examples as well. Okay, we cannot just skip them. Guys, the first two pieces are already done. We don't have to worry about them. It's just about just rewriting those things. So why don't we go ahead and actually distribute this 1/4, right? So it's going to be 1/4 of x, then plus, guys, this 2 and this 2 will already cross out, so it is just going to be sine of 2x divided by 4, and then there's this 1/4, and then guys, what about this 2? We can already take this 2 outside, and I'm only left with integral of 1 plus cosine 4x. Of course, there's a dx, right? We just distributed that 4 with all the 3 terms, and then this 2 is a constant. We got to take it out. We took it out, and anyways, guys, 4 times 2 is 8, so we can already simplify that. And all we have to do now is we just have to rewrite most of these. So it is 1/4 x and sine 2x over 4, and then I have 1 over 8. 1 over 8, guys, then again I will have 2 terms here. So integral of 1 is just with respect to dx is obviously just x, and then integral of cosine 4x will be sine of 4x, but you cannot just leave it as sine of 4x. You got to divide by the coefficient of x, or you can also think of that as the derivative of the inner. In this case, it is 4x, and the derivative of that is just simply 4. And then we have to put a plus c, the constant of integration, because it is still an indefinite integral. Guys, we're almost done. Let us just distribute this 1/8, and then we can just finally write our final value for the integral. So it's 1/4 x, that does not change. This is sine 2x over 4th, and then this is going to be 1/8 of x, and then plus sine 4x over 32 plus c. Okay guys, I think I just realized something. Well, this term and this term, they are not like terms, so we cannot combine them. But guys, this is an x, this is an x, so I think we need to combine like terms, and we should combine like terms. So we're going to combine these two, and that would be our final answer. So let us combine 1/4 x plus 1/8. So let us see if I can find some space for that. So guys, I'm going to show you how to do that. I hope that you guys can already do that on your own, but I'm still going to show you. Let us do it up here. So guys, I have to combine basically 1/4 plus 1/8. So not too difficult. We can just create a common denominator, right? We can multiply this by 2, so that will become 8. But if I multiply this by 2, I got to multiply upstairs by 2 as well. So this adds up to 2 plus 1 over 8, right? Because now I have a same denominator, I can combine the numerators. So 2 plus 1 is 3, so it's 3/8. Guys, 1/4 x plus 1/8 x, finally, instead of writing these two separately, they both add up to 3/8 x. So final answer is 3/8 x plus sine 2x over 4, and let me bring it closer. And then there is a plus sine 4x over 32 plus c. Guys, this is the final answer. Guys, I agree there was a lot of steps. I mean, even I had to like remove a lot of stuff and then rewrite things and bring things together. But guys, one has to deal with, or one has to do these type of examples when one takes a calculus 2 or even in calculus 1. So guys, please look at the steps carefully, take notes on the steps, practice it on your own, and I'm sure you will be more comfortable and more confident with these types of trig techniques. There's one more to go. I'm going to show you one more example, which is going to be completely different than any of the other examples that we have seen in the trig section of like trig techniques in integration. And then we're going to move to some different types of methods for evaluating integrals. Guys, till then, take care. I will see you next time.